So for Module 4 in Lecture 3, we'll look in a little bit more detail about matrices and arrays within MATLAB. And the first thing you might notice when I actually say that term is we haven't talked about arrays yet. So one of the things that I wanted you to be aware of is when you have a single dimensional, whether it's in a column structure or a row structure, collection of values, programmers tend to refer to that as an array, even though as engineers, we more commonly refer to it as a vector. So I will interchange those terms, not intentionally, but I wish I could stick with one, but I know I will go back between the two based upon my own experience of kind of straddling the line between the two disciplines throughout the remainder of the course. Another thing on that note that I wanted to say is remember that a matrix can always just be viewed as a concatenation. We'll define that term formally of vectors. So whenever I use the term matrix, that could also apply to a vector, since a vector is just a subset of a matrix. So we've already talked about ways to define matrices within the course. We've talked about this manual approach, and we've said that the syntax or the rules for actually defining matrices within MATLAB involve the use of square brackets in order to kind of enclose the multiple elements that make up the matrix. And in addition, we haven't talked about it explicitly, but we've used commas in order to kind of delimit. So delimit in computer science just means to separate values. So we've separated the values in a matrix so far using commas. However, you can also use semicolons. And the difference between the two is very meaningful. If you use a comma, what that will do is stay in the same row and go to the next column. Versus if you use a semicolon, you're telling MATLAB to go to a new row. So let me show you what I mean by that. If I enter, define a variable a, which is a valid identifier, it starts with a letter and contains only letters, numbers, and underscores, and I set that value equal, I assign it to opening square brackets, tells MATLAB to expect a collection of values in the form of a matrix. If I type something like this, what I'm telling MATLAB to do explicitly is in element 1, place a 1. When it sees this comma, the way that it interprets it is to stay in the same row and go to a new column. So in the same row 1, go to a new column from 1 to 2. When it sees the next comma, that tells it from 3, stay in the same row, row 1, and go to a new column, column 3. So it actually builds out the structure in a row. Versus if I were to do the same thing, define B with the same elements, but instead delimit it by semicolons, when MATLAB goes to kind of allocate this for you in memory, it says, okay, they want to call this identifier B. That's good. We want to set its value equal to, open square brackets. It's going to be some kind of matrix. First element is 1. Right when it sees that semicolon, it says go to a new row and stay in the same column. So it will go to row 2 in column 1, put a 3. Another semicolon, it will go to row 3, column 1, and put a 5. So that's the difference between the two delimiters, and it's very confusing until you just start to use it. So the key thing is not to memorize it, but actually get in the software and just play with defining some vectors and ask yourself what you get. So other useful approaches for defining arrays. Well, if you think about it, in engineering, we're often going to be working with matrices that have just thousands, if not millions of elements in like modern kind of neural networks. So we're not going to want to hard code and type in every element of every position. What will much more normally happen is we'll initialize them to certain values, and then we'll use some kind of mathematical operation in order to transform those values. So in terms of what's valuable for initializing elements of a matrix, there's a couple scenarios that always make sense. First of all, sometimes, and we'll talk about this a little more detail when we talk about the way that MATLAB is working under the hood, but it's always good to pre-allocate if you know how big of a matrix you're going to have, rather than kind of adding elements on incrementally to kind of reserve all that space in memory to make the program run quicker. So oftentimes you will just create a matrix that's got all zeros in it or all ones in it. Another very common thing is to create a matrix that has all random elements in it. That's very useful in modern AI algorithms for different reasons. I don't want to go into them, but you can kind of think that all training an AI algorithm is iteratively changing numbers in order to make the model fit your data more. So if you start with just all zeros, it's probably not going to get there as quickly as if you start with random values. That just kind of is intuitive to you, hopefully. So, and by the way, this is for the conference. I didn't go anywhere fun. Sorry. I'm actually a little bit, you notice it's 8:09 Central Time. I have my computer fixed to my usual local time. It's actually a little bit after 9 a.m. here, so a little bit behind. But there's 3 functions that MATLAB allows you or gives you access to in order to initiate matrices to specify values. If you want a matrix of all zeros, you use the zero function. If you want it of all ones, you use the ones function. Or if you want it to have random values, you use the random function. So I'm going to show you how to do this. I'm going to type into my command window CLC, which just basically means clear the command window. I'm going to type clear all, which will clear my workspace. And then let's just play with it. If you want to use a command that you don't know, the easiest way, other than just Googling the command, which is, to be frank with you, a way that I do more, the only way I use the command line is if I can remember the name of the function and I don't want to kind of go out of my application. So say the ones command. If you just type in the command window help and then the name of the function, note that it will actually give you the help file within the command window. And if we read through this, and I won't go into much detail because I like to keep the videos as short as possible, we'll notice that one of the ways to use this function, it's an overloaded function, meaning that there are multiple ways you can use it, is to pass in arguments corresponding to the number of rows and the number of columns. So if I did a 1 row, 5 column vector if I pass that into the ones function, notice that my result is a 1 row by 5 column vector of ones. So not too surprising there. Another very, very powerful operator that you want to know is the colon operator in MATLAB. And what that allows you to do is to define arrays in terms of their starting point, their stopping point, and the spacing in between them. So if you don't place a space in between, it will default to 1. But let's see how that works. Let's actually try to create an array that starts at 3, goes to, and you'll see why I'm leaving this blank in a second, goes to, 12, and has a spacing of 3. That's how the syntax looks. First element is start, last element is end, and this is spacing. So how it will create that array is it'll put a 3 in the first spot, and it'll say go over 3 more, which will take you to 6, go over 3 more, which will take you to 9, and it's only going to store every third element in the array. And you can see that that's actually what happens here. If you notice when I execute this command, my answer variable contains an array which has 1, 2, 3, 4 elements in it. It is a row vector by default, and the elements are equally spaced by 3. That's the value of the colon operator. Notice if I left that middle argument out, it still works. It's just defaulting to assume that the inner element spacing is 1. So oftentimes you do need counter variables that go up by 1, so that's a very valuable tool. An additional function that you want to be aware of, and notice that I hyperlinked a lot of these to the MATLAB help page if you want to read in more detail, is the linspace function. So linspace allows you to create an equally spaced array, just like the colon operator, but only it's more valuable in the cases where you know the start and stop point and the number of points, if it's not going to be spaced by an integer. So the way this works is this. If you have linspace and you want, the minimum value of your array, and you can kind of see when you start to type, it gives you some hints on what the syntax is. So oftentimes I will not worry about looking up, and I will just look at the format of the arguments. Okay, x1, x2, n. Well, I remember linspace goes from a start point to a stop point, and then I specify the number of points. So say I wanted to create an array from 5.5 to 9.3 with 100 elements. Think about trying to do that with colon notation. What a pain that would be. But notice when you do it this way, you get your 100 element array. And let me actually remember that by default, if I don't assign the result of a command to a variable, it's in the answer variable. Let's look at the answer variable. It's a 1 by 100. So again, it's going to be a row vector, and all these elements are spaced by whatever spacing is necessary in order to cover that range. That's the way that you can think about linspace working. In addition, we can compute mathematical functions on basic matrices. So if I have a simple matrix, maybe a 10-element vector starting at 1, spaced by 1, and going to 10, I can take the sign of each of those elements and create a new vector. So the way that I would do that is if I had x defined from 1 to 10, that's a vector or an array, depending on what you call it, and I define a new array, y, and I set its values equal to whatever I get when I take the sign function of each element in x. That is valid syntax. And you notice that each value in y corresponds to the sign of the values in vector x. So whenever you use a mathematical function in general, and we'll talk about the more complicated case when you actually pass in a matrix into a mathematical function. But when you're passing in just a single dimensional vector or array, the resulting array that you get has the same dimensions. So some other things that you should know, you can create matrices of kind of arbitrary dimension by putting together or combining kind of like Legos individual arrays or matrices. And that process is known as concatenation. So let's see how this works. If you have vector A, which is defined by syntax open square brackets 1, comma 2, remember that's just going to be a row vector of 2 columns with elements 1, 2. And then you have the same thing for B. So I'm just going to type this out how it looks. So here's the way that these two vectors look, A and B. What I'm trying to do here is create a new vector C, and I'm going to put it together how? Well, up until now, these have all been fixed numbers. They haven't been variables. So MATLAB, what it does is it says, okay, well, what does A mean? It goes into memory, and it remembers that A is a row vector. It says, okay, so put a row vector in here for the first element. Well, that's not really the first element anymore, but it's just telling, okay, starting at 1, 1, put in the row vector A. Well, that's 1, 2. And then it's sitting here, and it's like, what do I do next? And it sees that semicolon. Remember that the semicolon delimiter tells it to go to a new row. So it says, okay, go to new row. Got it. And then what do I do next? Well, they want me to put B in there. So look up what B is. B is 3, 4. Put 3, 4 in there. And I can do that because notice that I'm putting B beneath something that has the same size as A. It is also a 1 row by 2 column row vector. So this concatenation makes sense. So when you put a 1 by 2 row vector together with a 1 by 2 row vector, you actually create a 2 by 2 matrix. And that's not too surprising. I'm just going to clear everything up and show you how this would work. Create A, 1, 2. Don't use a period. That will confuse it. Create B, 3, 4. And then create C. And I should have suppressed that output. You don't have to. It just makes your workspace cleaner. That's why I keep having to clean mine. You'll notice that C, if I don't suppress the output in order to see it, is that 2 by 2 matrix that we expected. And one thing I noted here is, actually, let's go through ways to reshape matrices. We talked a lot about the transpose. So if I take A, notice that it's a row vector. If I take the transpose of A, it'll give me a column vector. Another way that I could take a transpose is just with the apostrophe operation. So that's a common scenario in MATLAB where there are kind of multiple syntaxes that do the same function. In addition, if there's the reshape function, we're not going to go into it right now, but that's for more complicated, kind of taking elements in a matrix and leaving the elements the same, but reshaping them in some desired way. So in addition, we can check the size of any matrix in MATLAB by always just using the size function. Size function, you pass into it the matrix you want the size of, and it gives you back the size. So for C, it's a 2 by 2 matrix. For A, it's a 1 by 2 matrix. And remember, you can also get those by clicking on the variable in the workspace and actually reading out. So let's do some example problems. A is 1, 3, 4, a row vector or a column vector. Well, that's just going to be a row vector, right? Because remember that the column delimiter tells MATLAB to, in the same row, go to the next column. So when it's interpreting this, it goes into memory and it says, okay, I'm going to call something A. I'm going to set it equal to, I see the square brackets. It's going to be some kind of matrix. First element is a 1. By default, when it sees a 1, since this is a loosely typed language, it will allocate enough position for a double. When it sees that comma, remember that what it's going to do. So always just kind of go into Notepad and ask yourself what's going on. And I would write, but unfortunately I'm in a hotel, so I don't have my napkin. So how does this look? It puts a 1 in there. When it sees that comma, it goes in the same row to the next column. So same row, 1 to the next column, 2, and puts a 3. Another comma, same row, next column, it puts a 4. So what does that create? Just look at it. That's a row vector. It's a 1 row by 3 column row vector. Let's do the next thing. Specify the size of B. Notice that when we form B, it says, okay, they want to call this B, go into memory, set that value equal to, well, I see a square bracket, it's going to be some kind of matrix, put the element 1, 1 as 2. And it sees that semicolon, that tells it not to go in the same row to a new column, but in the same column to a new row. So it's going to say, okay, I was in row 1, go to row 2, put a 3, another semicolon, okay, and that was a -3, sorry. I was in row 2, column 1. When I see the semicolon, I go to a new row, same column, put the -4. So that's going to create a column vector, and that is going to be 3 rows by 1 column. And remember, column vectors always have 1 column, row vectors always have 1 row. So let's do the next one for C here, specify its size. How is C being entered? Well, starting at position 1, 1, it will have the elements 1, 3, 4 delimited by commas. That's going to create a row. and then it will have a semicolon that's going to tell it to go to a new row, and it will have the elements 2, 5, 7 all in a row. So that's exactly like the example we looked at during the explanation of the lecture. I'm going to have 2 rows, and each row has 3 columns. So this is 2 by 3. So next question, would the following definition produce a syntax error? Why? Try to execute the command and note the resulting error. Well, let's just do that. Remember, when you copy and paste into MATLAB from like a marked up element, like a marked up document, like the productivity suites of Word or PowerPoint, oftentimes it will add additional information into your paste. So if you paste and get a syntax error, don't worry. It tends to happen more when you paste ASCII codes for text. So that's why I didn't copy the D, and I wrote it in manually. So notice I did get an error. That's what it's telling me. Dimensions of arrays being concatenated are not consistent. Well, what's it talking about? Well, notice, what did we try to do? We tried to take 1, 3, 4, which is going to be a 3-element row vector, put a semicolon underneath, which says go to a new row, and then concatenate in a 2-element row vector. So basically what we were trying to do was this. Put 1, 3, 4, I think that was, make sure I get the right entries, with 2, 5. So what MATLAB is saying is, hey, when you started this array, you told me the first row had 3 elements. Now you're telling me the second row only has 2 elements. I can't put those together because I have to, it's like your Legos. You have to put together blocks that fit. So that's what a vertical concatenation error means. And you notice vertcat is telling you how MATLAB is doing this. It's defining a row and it's vertically concatenating it with another row. But since they're not the same width, another term for number of columns is width when you think about it written out. It can't do that concatenation. Use a help function command to better understand the function syntax. Use the one function to create a 10-element column array of ones. Well, remember, we already looked up the syntax of the ones function. What you do is you just pass it in so let's just show you again, help ones. There's a version of this function where you can pass in the number of rows you want and the number of columns you want. So let's go back and see what we wanted. We wanted, where are we at? A 10-element column array. So when you think about a column array, that will have 1 column and it would have 10 rows. Remember, by definition, M, the first entry, is the number of rows, and the second entry, N, is the number of columns. So that's the syntax I would want to use in order to generate a 10-element column array of ones.